Hey everybody out there and at home watching along, following along. I should start live streaming rather than just recording. I'll get my own Twitch account.
You can also
send me
record
money.
live with.
I could just record live with YouTube.
I mean,
Take donations,
you have to
yeah.
go to YouTube Studio
I could
for
raise,
the whatever.
Sell my own merch. What could I sell as merch? I'm at 91 right now. I'm at 91. I could sell like
Math memes.
I could sell like pencils. Like you can order pencils or like calculators. Would you buy that?
No. Yeah.
All right. So section 4.3 is now writing the functions, creating the functions, writing the functions. Okay, so first thing we want to do is determine the relationship between the x and y values. What type of relationship do you see? How do I get from x to y? If I plug in x, what do I do to it to get to y? Tyler, what do you think? You divide by 5? I would agree with that statement. If you think about like, okay, I think it's this. I think it's divide by 5. Y is equal to x, and then we divide by 5. Test it out for all data pieces. For example, if I plug in 5, does it get me to 1? If I plug in 10, does it get me to 2? Yes. Here's what would not work, right? Y is equal to x minus 4. Does that work for 5? Does that work for my first piece of data? Yes, but does it work for all? No, it has to work for all. Good. Okay, there's my equation. Y is equal to x divided by 5. Okay, so what's my next one? What's my next one? Nate?
Multiplied by 3.
So what's my equation? Y equals what?
Y equals 3x.
Y equals 3x. Let's check, make sure. If I plug in 1, I get 3. If I plug in 2, I get 6. If I plug in 3, I get 9, and so on. That pattern will continue. Good. So what we're doing in this section is looking for patterns and creating the equation from that. I mean, that's not all we're doing. And the equation in example 1 describes a function because for each x value input, there is one and only one output. Now, the input of the function is called the independent variable. The output of the function is called the dependent variable. Remember, the independent variable is what you plug in. The output is what you get out. So, for example, in those equations, my input was x, my independent variable was x, my dependent variable was y. That's what I was generating with those functions, right? Now, when I start to put it into word problems, it's going to be important that you identify what the independent versus dependent variable are, because when you go to graph, the independent variable is going to be on the x-axis, and the dependent variable is going to be on the y-axis. So we're going to take some time defining the independent versus dependent variables. So, for example here, a painter must measure a room before deciding how much paint to buy. Okay, a painter must a painter must measure a room before deciding how much paint to buy. What is the independent variable here? What is the independent variable? What do you think, Liam? The measure of the room. Good, the measure of the room. If I change the measurement of the room, what else changes? The dependent, which is how much paint. Right. See, you have to word it like that. You have to think about, okay, the independent variable is the thing that should change. It's independent, right? It doesn't depend on anything else, right? So therefore, the independent is going to be the measure of the room. The dependent is going to be the paint, the amount of paint. Okay? You should always be able to say, if I change my independent variable, it will force my dependent variable to change. Think about it, if you had accidentally reversed it, and you said the independent variable was the amount of paint, Can I change the amount of, I mean, if I change the amount of paint I buy, should that change the size of the room? Like, that does not make sense, right? Okay, so let's take a look here. A veterinarian must weigh an animal before determining the amount of medication. So what's the independent variable? What's the independent variable? Carson? The weight of the animal. Good. Okay, so what's my dependent variable? If I change the weight of the animal, what does that force to change, Liam? The medication. The amount of medication. If you had accidentally flipped that, you would have said, oh, if I change the amount of medication, it'll change the weight of the animal? But that doesn't make sense. A buffet charges $8.95 per person. What's my independent variable in this situation? What's my independent variable in this situation? The number of people. Good, the number of people. Independent is the number of people. Dependent, if I change the number of people, what's going to happen then? Kenzie? Good. Total cost. Good. Okay. Now, there are several different ways to describe variables of a function. In all of those situations, those were all functions, right? We've talked about what does it mean to be a function. Well, you know, we can describe the independent variable and the dependent variable as x or y, right? Okay, but we can also say the x values are the domain and the y values are the range. Another synonym there would be the input and output. Now, if you call this a function, if it meets all of the requirements to be a function, you can use this special notation. Okay? Normally we would think x and y would pair together, right? But if you say that it's a function, you can say that x and f of x. That's how we read that. We read that as f of x. F of x. That's how you read that. F of x. That is the function notation. It's saying the function f with the variable as x. Okay? That's if it meets all the requirements to be a function. Okay? That's if it meets all the requirements to be a function. Let's keep talking about that a little bit. An algebraic expression that defines a function is called a function rule. Remember, we talked about that the other day. If I say the word rule, that just means an equation. An equation, okay? Now, if x is the independent variable and y is the dependent variable, we can use this f of x. Talking about it a second ago. F of x notation. Here's what I mean by that. Guys, how long, you have to be in school for a really long time to become a doctor, right? You have to be in school a really long time to become a doctor. What happens if you go to a doctor and you just, like if I was Dr. Laverick, and you come up to me and said, hey, Mr. Laverick, what might they do to you? They might say, no, it's Dr. Laverick. Right? Ever have that happen to you?
No.
No?
Yeah.
Maybe when you get to college, because a lot of college professors are doctors of their. A lot of times when you get to college, your college professors will be doctors of their specific subject, right? Because you could be a doctor of anything. You don't need to be just a doctor of medicine. But so some of your professors might be a little picky. If you go up and call them, like, hey, because we had a professor called Dr. Her name was Dr. Moss, right? So if I went up to her and I said, hey, Mrs. Moss, she'd say, no, Dr. Moss. They would be a little bit picky. Do they have the right to be picky? Yeah, why? Because they went through all of the certification, all of the qualifications, all of the schooling to meet the requirements to be a doctor, right? So this kind of like is the same thing. if an equation meets all the requirements, goes through all the things, passes the vertical line test, every x value is 1 and only one y value. If it meets all the requirements to become a function, use the special notation, okay? Use the special notation, that f of x notation, okay? It's just a new way of writing it. What does it mean? Well, really, y just means f of x, okay? It really means the same thing. When you say y equals mx plus b, you could really say f of x equals mx plus b. That means the exact same thing. Y and f of x mean the same thing. Why do we use f of x? Well, to tell the reader that it's a function. And it's meets all of those requirements. Okay? So let's take a look here. Identify the independent and dependent variables and then write a rule in function notation for the situation. A math tutor charges $35 per breaking in the dough. Math tutor charges $35 per hour. What is my independent variable here, David? The amount of hours. Independent is the amount of hours. My dependent would therefore be what? Go ahead, David. Money. The total charge, right? Okay. So if we call the independent variable x and the dependent variable f of x, now somewhere along the way, one of my professors was using this notation, this like really fancy looking f, and I just picked that up along the way. Just know that that's just like a cursive EF. So what we can say here is my equation would be, if it's $35 per hour, it's 35x. 35x, right? And we would normally say y equals 35x, right, to write that equation. But since we know that it's a function and we want to use this special function notation, we say f of x is equal to 35x, okay? Would it be wrong to say y equals 35x? Yes. Would it be wrong to just say 35x? Yes. You have to say, if I say write it in function notation, you have to say f of x equals 35x. Now, the cool part about function notation is that you can change up the letters to make it fit the scenario. Like if I wanted to fit this scenario here, okay, maybe I called the independent, so this amount of hours h, and then the money, the maybe we'll call the charge c of h. Okay, that f is just the function name. Why do we use f? Because that's the first letter of the word function. So you can change up that name of the function. We could have said c of h is equal to 35h. That means the same thing. Okay. You can change up the letters to match the context of the problem. Okay, a fitness center charges a $100 initiation fee plus $40 per month. Okay, what is my independent variable here? What is my independent variable? Bigger?
Is it months?
Months. What's my dependent variable then? If I change the amount of months, what's then going to change? What's then going to change? Lee?
The total cost.
Total cost. Okay. So let's be boring. Let's say x and f of x. Okay, if my equation is I have $100 plus $40 per month, 40x. Here's my equation in function notation. F of x is equal to 100 plus 40x. You know, before today, we probably would have said y equals 100 plus 40x. But now, since we know it's a function, we can use this special notation. Something else that we can do when we evaluate functions, meaning just plugging them in, is we can actually just use this function notation to plug them in. And let me show you what I mean here. Look, I've got h of c. That's how we read that, h of c. Just changing up the letter, changing up the independent and dependent variable letters. H of c when c is 4. Okay, that means I want to find h of 4. Ooh, look at that. If c is 4, you plug in 4 to not only the right side, but also the left side. 2 times 4 minus 1. Please know that this is not like h times 4. No, it's just a notation. Okay? It's just a way of writing it. So you say, okay, h of 4 is 2 times 4 is 8, minus 1 is 7. H of 4 is 7. Okay, if I wanted to find when c is negative 3, you now plug in negative 3. So 2 times negative 3 minus 1. Notice that all I did was take this equation and in place of c, everywhere, left side and right side, we write our input, negative 3. Let's evaluate. So h of negative 3 would be, okay, 2 times negative 3 is negative 6, minus 1 is negative 7. Voicemail from that. I guess I'll check it out. Okay. All right, questions about that? That's just a special type of notation for functions. Okay. Again, like I said a second ago, when a function describes a real-world situation, every real number is not always reasonable for the domain and range. For example, a number representing the length of an object cannot be negative, and only whole numbers can represent number of people. Okay, so it says write a function to describe the situation, like we just did, and then find a reasonable domain and range. A reasonable domain and range. When I say reasonable domain and range, I'm saying, what are the types of x values that I could plug in? Okay, so in function notation, well, what's my equation here? The cost is $100 deposit plus $200 per hour. What would my equation be? $100 deposit plus $200 per hour. Tyler?
100 plus 200.
Good. And if we're using this special fancy notation, we write f of x is equal to that. Now, it says it can only be rented for 2, 3, or 4 hours. So what's my domain? What's my domain? 2, 3, 4. This is my reasonable domain. People, if I had not said that it could only be rented for 2, 3, or 4 hours, you would say the reasonable domain would be any whole positive number, right? 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 6 hour, probably all the way up to 24. That's a reasonable domain. I mean, would you rent for 24 hours? I don't know. Now, it says to find the domain and range. How do I find the range when the x value is 2? I got to plug it in. I got to plug in 2, 3, and 4. I plug in 2, I get 400 plus 100 is 500, 700, 900. So my reasonable range would be either $500, $700, or $900. Okay? So that is function notation. Function notation. Okay. Questions about that? All right, let me stop the video here.
Where are we gonna go?